Hi guys, welcome to my channel. Today let's solve it as a lead code question. The description of the question is as follows: that we were given an m on n integer matrix points, which is zero indexed, and we do initially have. So I'll just write node points. Initially, we have 0 points with us. We will need to maximize the number of points you can get from the matrix. Okay. And for gaining the matrix, we were given that points RC will be added to our score, and also absolute of C1 minus C2 will be the penalty. So currently, if we took the points at row 0 and column 2, and later we went to row 1 and took points at column 0, then our total points would be points of 0 to 0 2 plus points of 1 0 plus, and it should be absolute of 0 minus 2, because we ended up at column 0 from column 2, so 2 will be our penalty. So this would be our final answer. So we need to find maximum points that we can collect. So how can we do that? So first of all, let's just take the example 1 into consideration. The example 1 is as follows: 1 2 3 followed by 1 5 1 followed by 3 1 1. So here what I'll do is I'll just consider one row each at a time. So over the first iteration, because for from going for one row to next row, we only need to check the absolute difference of the columns for the penalty. So from going from 1 to 3 directly is not possible, and there's an intermediary node or row, that is 2. So 1 to 3 needs to be gone via 2. So first iteration would be 1 to 3 itself, and for 1 to 3, if there's only one row 1 to 3, then there won't be any penalty, and we'll be obviously choosing the cell that's having the maximum points. So if only 1 is there, then my answer would be 1. If only 2 is there, my answer would be 2. If only 3 is there, my answer would be 3. So if I ended at this cell, or if I chose this cell, then the maximum points that I could achieve if only first row is present is 1. If the same is happened with the second cell, then the maximum score that can be achieved, or the maximum points that can be achieved, is 2. And for the third cell, the maximum points that can be achieved is 3. Right? Now considering for the second row. So considering for the second row, from the first row, we could either come from this, or this cell. So from coming for the first cell to the second row, we could either come from any of these three cells. So I'll just check if I'm coming from the first cell of the first row. I'll just write penalties first here. Penalties coming from the first row would be 0. So, or I'll just write I'll just write maximum of penalty plus pre-row score. That will be the one that I'll be choosing, right? Because if my penalty and previous score added together will be the maximum, then obviously that will be my optimal choice to end up in the second row at that cell. So I'll just check the maximum of penalty plus previous row score for first cell. So if for the first cell, the penalty would be 0 and the previous row score would be 1 if I consider coming from the first cell. And that would be, penalty would be 1, so it would be minus 1 plus 2 if I'm coming from the second cell, and it would be minus 2 plus 3 if coming from the third cell, because penalty would be minus 2 because here's column is 2 and we need to we are considering of going to column 0, so penalty would be minus 2, and the score is 3, so it would be, in either case the answer would be 1. So for the first column it would be 1 only, and for the second column I'll just remove this. And for the second column, if I need to come from the first row, then the penalty would be minus 1 plus 1. That's 0. Coming from the second row, it would be 2 plus 0. sorry, I'll just write it here, minus 1 plus 1, and it would be 2 plus 0, and followed by the third cell it would be 3. Penalty would be minus 1 because I'm going from minus, sorry, 2 column to 1 column. So absolute of 2 minus 1 would be 1, or absolute of 1 minus 2 would be 1, and the score that's present in the previous row is 3. So in either of these cases, the maximum score that I'll end up with is 2. Similarly, for the third column as well, if I check coming from the first row or first cell of the first row, then the penalty would be minus 2 plus 1. I'm coming from the second row, second column, the penalty would be minus 1 plus 2. Coming from the third row, third column, it would be 3 plus 0, or penalty would be 0 plus 3. So obviously what I'll be choosing is, I'll be choosing for coming for the second cell, I will always be choosing the above row first column. And these are considering only the penalties, sorry, above row third column. These are considering only the penalties and the previous row score, but I do have the current row score also added. So if my current row score is added, then that would be 2 plus 5, and this would be 3 plus 1. So in this case, what's the maximum value? 2, 7, 4, and that's 7. So I'll just end up over here, or I'll just consider the maximum as 7, and that's done of it. So now we'll be having 2, 7, 4, and again we do have the third column 3, 1, 1. Now we do have the previous row and the current row, and similarly to the first or this case which we done in the above iteration, we'll do the same over here as well. So this is dynamic programming, or this is recursive calls, I'll just say, i.e. I'm performing the same operation on multiple subproblems. More clearly, here different subproblems are considering the previous row and the current row. So these are the subproblems that I'm having, and that's done of it. So we just solved our first example. I'll just give you the intuition now how I'll be doing that. So for doing that, I knew that I need a previous row and the current row. So for computing the current row points, I do have two options. First one is, I'll just take the above row of it, or the exact same column of the above row of it, then there would be penalty 0. Sorry, penalty would be 0 in that case, and my current score would be added. That's if I consider this as row C and column, row R and column C, then that would be points of RC would be added. That's the first case of it. But the second case would be, if I do not consider the exact vertical above column, then I could consider some column to the left part of it. So if I consider the column to the left part of it, then that would be, I'll just compute the left max that can be happening till the particular column. So in general, what I'll do is, if I am having three different columns, I'll just say A, B, C, and my current column points maybe x1, x2, x3. So for computing the points at this column, I could either consider the row or the column that's vertically exactly opposite to it, or exactly upwards of it. That would give me penalty 0. Or I could also consider the column that's present to the left part of it. Why only left part of it? Why not the penultimate left of it? For example, if I consider A, B, C, D here, x1, x2, x3, x4. Why for x3 I'm just saying I'll just consider either the C or B. And why not A? Because while considering x2 itself, I'm already incorporating A. So the subproblem is already incorporated in x2. So for x3, I'll just need to consider the left part of it, which is again x2. That's no need of considering A again, because x2 already contains the result that obtained when we considered A. So that's how it works. So I'll just call rows as points. Number of rows would be points dot size, and I'll just call number of columns to be 0.0 of size. So as I already told, I'll just need to maintain the previous row. So pre row will have how many columns? That would be having columns of zeros. So initially that would be filled up with the first row elements, because previous row always starts with the first row. If I considered adding the number of rows, or consider computing the rows from the first row, because previous row in that case would obviously be the first one only. So here my pre row of I would be points of the first row, that's 0, columns, that's I. So that's done of it. And now I'll just iterate from my row, and row should be less than or less than rows minus 1, row plus plus. Why this should be less than row plus 1? That's obvious, because at the current iteration I'm computing the left max of it, and for the I'm computing left max to get the points that are possible at the next row. So if I did this for up till rows, then in this inside for loop I'll get points of row plus 1, which would be out of bounds, because I'm taking the current row, I'm considering the points that could be obtained for the next row. So this should be going from row 0 to rows minus 1 only. In that case only, we'll just consider the current row and the points obtained maximum for the next row of it. So similarly to the left, first I'll just compute the left max of it. And you knew that this is a grid. So for coming from x3, I could either come from the left side of it, or I could come from the right side of it. So either way is possible. So I'll just compute the left max and similarly the right max as well. So I'll just call vector long left max and calls 0, vector long right max calls 0. And for current row also I need to compute, so this should be current row, and current row value also should be having calls 0, right? Now what I'll do, so for initially at the left column of it, I do not have anything from which I could come from the left column. Like if I'm at this element, I have only one option that could be coming from, that's this position. If I consider only left, I'll be traversing from the left side, not considering the right side. So if I'm at this position, I'll be able to come only from the above vertically cell, and I couldn't be coming from the left part of it. So left max of 0 is always equals to my previous row of 0, because I'll always be coming from the above vertically cell. And for int call is equals to 1, call is less than or equals to columns, call plus plus. I already told you for the left max of call would be what? Left max of call would be, if I considered I'll be coming from the left part of it, then that would be left max of call minus 1. I am coming from the left part of it, minus 1. Why this minus 1? Because this minus 1 will be my penalty. So I'm at this column and I'm saying that I'll be coming from this column. But from this column coming to this column will add me a penalty 1. So that's minus 1 representing. Because that's a penalty, so that's subtracted. And if that's not the case, then I'll come from the above vertically column. That's pre-row of call. So we computed the left max part of it. So I'll just compute the right max part of it. So right max, similarly, if I'm at this position, I couldn't be coming from the right side of it. Do not consider that I'll be able to traverse from the left side of it also. So right max of call minus 1 would be what? Pre-row of call minus 1. And that's for sure. And here for int call is equals to, this should be calls minus 1. I'm sorry for that. So for call equals to calls minus 2, that's the exact opposite. Call would be greater than or equal to 0 and call minus minus. So what it would be, right max of call would be equals to max of right max of call plus 1, because I'll be coming from the right side of it, and penalty would be minus 1 in this case as well. And either I could come directly from the above vertical cell though, so that would be pre-row of column. Now we do have that for this cell, left max is already computed, right max is already computed, and the current cell points is 5. So for int call equal to 0, call less than calls, and that needs to be done for every column of it, right? So I'll just say cur row of call that would be equal to maximum of left max of call. If I am coming from the left side of it, and right, if I'm coming from the right part of it, then it's right max call. And I'm also having my current points as uh, this row plus one and current column, right? So that would be points of row plus one and current column. Current column points are call. So got the point. Here left max and right max are computed for the previous column. So coming for this column, I'll be having the points that are already stored with me. That's points of row plus one and column. And I'll just check which will yield me the maximum result, either coming from the left side of it or right side of it. So that's done of it. Now going to the next row, I'll just change my prev row as current row. And my long ands would be initialized with 0. So I'll just traverse through all the calls and my answer would be max of answer and pre-row of column or pre-row of I am sorry. So that would be written answer, or initializing with long min I guess would suffice, because what if points are 0. I was missing something over here. So this should be less than equal to calls. I'm sorry for that, because we are using a zero index value, right? So this is working fine. Let me just submit this out. So it's perfect. We bet 30% people with our complexity. So I'll just reduce the time by specifying that my C compiler or C++ compiler not to load any functions or headers from C that will be useful for taking in or giving output to console. So I'll just specify do not tie any libraries or headers that will be helpful for taking input and giving output. So I'll just submit this. You could see now it's fairly reduced to 172, and we bet 81.20 people with our comments. Thank you. Feel free to add anything in the comment section if you think anything is unclear.